Here we go. Answers to quiz number 1. Anybody away last day and didn't get a copy? You got the copy of the quiz. It was you were the only one. Excellent. And Sirki, she gets everything right. Number of variables. Okay. Shh. Quiet, please. Number of variables. 1. Letter A. Number of terms. 1, 2, 3, 4. 4. Name of the polynomial. We would just call this a polynomial. I'll abbreviate it with the word poly. The degree. 6. 1 mark for each of those. Number of variables. 4. A, B, C, R. Number of terms. 3. If it's 3 terms, we call this a trinomial. And the degree is 3, because it's A to the 1, B to the 1, C to the 1, 1 plus 1 plus 1, 3. Number of variables, none. Number of terms, 1. This is a monomial. It's also a constant term, but it's a monomial. Degree, 0. There are no variables. Number of variables, x and a, 2. Number of terms, likewise, 2. So this is called a binomial, and the degree is 4. If you want to make life easy, you can give yourself a little score out of 4 by 4, 16 right there. That would work well. Complete the following table. What's the leading coefficient? Some of you were forgetting what the leading coefficient is. The leading coefficient is, first of all, find the biggest degree term. The coefficient is what's in front of that one. In this case, the biggest degree term is this one. In front of there, it's a 1. The constant term is a -9. The degree is 3. No, that's completely different because x is a variable, not a coefficient. I have to mark that one wrong. Sorry. So mark that one wrong. It's what's in front of the x. I'm going to take a half mark off and give you the frowning of a lifetime, yes? Leading coefficient here is going to be -11. Because remember, the coefficient was the number in front of the variable. So if you include the variable in front of in the coefficient, it's no longer the number in front of the variable. It's the number and the variable, which is a different definition. Does that make sense? Good. And by the way, this half mark will cost you nothing, but you'll remember it for the rest of the year on the tests in the provincial, which is one of it. Right? Any mistake you make here is a good thing. Constant term, 15. Positive 15. A degree, 3. Leading coefficient, -2. Constant term, √7. Whatever the heck that is, I don't care. I know there's no variable, so that's the constant term. Degree, also 3. Leading coefficient, 3/5. Constant term. Oh, I guess 0, or you could say none, or you could put a line, or there is no constant term, or if you're fussy, it's a 0. Degree, 5. You can give yourself, if you want to, a little score out of 4 by 3 out of 12 right there, if you really, really want to. State whether or not the following are polynomials expressions. There should be polynomial, should be an S on there. If they're not polynomial expressions, explain why not. Yes. Yes. What about C? No. Half mark if you said no, and then a half mark if somehow you did that. Because explain why not would be, or you could have written out the exponents have to be whole number. It's easier to circle the glitch. Simplify. 2a minus 16b minus c. Is that correct? Yeah. This is worth 1 mark. How many terms are there? Half mark off for each term that's wrong. So if you get 2 wrong, sorry, you get 0 on this question. B, 6x minus minus, which is a plus, which means minus 5y. 2 terms, 1 mark, half mark for each term. C, let's see if I can do this all in one fell swoop. There's going to be a negative there, there, and there. Okay. I'll get a 2x squared minus 5x squared which is negative 3x squared, negative 1x squared, I think. 3x and 5x is 8x minus, hang on, Mr. Duick, this is wrong. I'm reading the question wrong. It's not a 2x. Let's try that again. 2x squared plus 5x squared, I'm pretty sure is 7x squared minus 3x squared. How about let's go with 4x squared for your first term? Wow, Mr. Duick. That was terrible. 2x, oh, good gosh, Duick. I'm way off. I'm slumping. Let's try this again. Mr. Duick, don't do this in your head. Instead, underline the like terms, because this is where you're having trouble for some reason, because the like terms are in wonky orders. 2x squared plus negative 5x squared, the same as 2x squared, take away 5x squared. That's negative 3x squared minus 3x squared. How about let's go with negative 6x squareds for Pete's sakes? Is that better? Yes. Cross out the x squareds, Mr. Duick. Let's do the x's next. Boom, boom, boom. 3x plus 5x is 8x minus minus, which is a plus 2x. Do you get positive 10x? Oh, thank goodness, Mr. Duick. Good gosh. And then I have negative 9 plus 8 minus 4. Negative 9 plus 8 is negative 1. Take away 4. Please tell me it's a negative 5. Is that right? Woohoo! 3 terms, half mark off for each term that's wrong. So you can get a half mark. And then I should probably, because I got this one wrong initially, say, let's see, I got that one, I got that one, I got that one. Is everything crossed out? Yes, there we go. Can you, is this quiz out of 34? I got 16, 12. 16 and 12 is 28, 29, 30, 31, 32, 33, 34. Give yourself a score, please, out of, count them, 34. And once you've given yourself a score out of 34, look at any mistakes that you made. So can you get out assignment number 3, please? I think you probably got this done in class as well. So we're using the concept of tiles. I think I've expressed to you, Amy, that for my brain, the way I think, I find the visual stuff not as effective, but I've read research and they claim that some kids find the visual stuff effective, and if you're one of those, God bless you. Probably also means you can draw better than me, which really isn't much of a challenge. So what we said is, which ones are negative, the empty ones or the shaded in ones? Oh, empty, negative, nothing. Okay. So we said the idea we wanted you to realize here is those cancel. Those cancel. And I told you I didn't want you to write the addition sentence. I said, I'm just happy, tell me the answer. I think we end up with this, do we not? A negative x, sorry, not negative, positive x, Mr. Duick, shaded in as positive. X plus 4, is that right? B, we would say, you know what? That will cancel with that. And I think we'll have a positive 2x squareds, a single negative x, and a negative 1, because it's hollow. You guys can see that you have a square right there. It doesn't appear on the projector, but my bulb's dying. C, let's see. Well, that'll cancel with that. Both of those will cancel with both of those. So I'm going to have negative 2x squareds, no x's, and then 1, 2, 3, 4, 5, 6, 7, 8, positive 8? Yep. Okay. And then I also gave you, I believe, assignment 4.
Assignment 3 was double-sided. Yeah.
Oh, assignment 3 was double-sided for you guys? Oh. Sorry, I thought that was where it started. I started at section C. I gave you section B as well, yes? Yes. Gotcha, my bad. No wonder you were a little confused. How about 3x plus 3? How about negative 3x plus 3? How about 2x squareds, negative 2x's, and a positive 1? How about negative 2x squareds, positive 3x's, plus 2? Is that all of them this time? Okay. Hang on to that one for a second. I'm not going to give you 31 marks for that because I cut it shorter from the original one. I'm probably going to give you just a 10 out of 10 for doing it. Can you get out assignment number 4, numero cuatro, this one here? And I think all I assigned for you folks was question 4 and question 5, yes? Okay. For A, 42x minus 18. 4b, negative 16x minus 36. 4c, 8x squared plus 32ax, or you could have written 32xa, but I choose to go alphabetically when I can. 4d, negative x squared plus 5xy. Did I do any wrong on that page, or are we good? Aside from my atrocious handwriting. Turn the page. 4e, 3x minus 6y plus 9z. Negative 2a squareds plus 10ab minus 8ac. Yeah, I hope. B squared minus 2b cubed plus 3b to the 4th. Negative 8x cubed minus 4x squared plus 8x. Number 5, expand and simplify. 3x plus 15 minus 7, it's going to be 3x plus 8. 4 minus 6x minus 18 is going to be a negative 6x, and then 4 take away 18 minus 14. You could have written negative 14 minus 6x, but if we have a choice, we usually go, if it's one variable, biggest degree to smallest degree. So our answers look the same. Is that right so far? 5x minus 10 plus 3x, I'm pretty sure is going to be 8x minus 10. 3x squared minus 9x minus 2x squared plus 2x. It's going to be x squared minus 7x. I'm amazed I haven't made a mistake yet. Oh, I will here. Let's see. AB minus AC plus BC minus AB. I know it said BA. I'll write them alphabetically, and that way when I'm looking for like terms, it's way easier for me to spot them because I've written the letters in alphabetical order. Just a hint. Plus AC minus BC. I can gather some like terms. Hey, I think the ABs cancel. Hey, I think the ACs cancel. Hey, I think the BC... Is this whole thing 0? Nothing? Yeah, is it? Now, if you left it blank, Simi, that I would have to take a mark off because blank is not, you're saying, actually, no, I know the answer. It's between negative 1 and positive 1. It's exactly 0, which is different from leaving it blank. Right? That one was kind of cool in a nerdy sort of a way. Here, I'm going to drop the 20a cubed c cubed down. I'm going to multiply this on because there's a minus sign, so it doesn't mean it means I don't multiply this. Let's see, it's going to be minus 12 a to the 4th c squared minus 20 a cubed c cubed plus 4 a to the 4th c to the 3rd. Can I gather like terms here anywhere? Hey, those guys actually cancel? Yeah? So I end up with a negative 12 a to the 4th c squared and a positive 4 a to the 4th c cubed. And tempted though I am, those are not like terms because one's a squared and one's a cubed. Is that right? Am I right?
Yep.
Okay. So put your name on both assignment 3 and assignment 4. Pass them inwards and I'll come grab them. So, lesson 3, we looked at multiplying monomials by monomials and monomials by polynomials. Now we're going to do binomials by binomials. You probably last year learned an acronym for this. You probably called it FOIL. Okay? Our goal this year is if I give you a clean, a fairly straightforward binomial. My screen is flickering, by the way. My projector's on its last legs. I'll try and get a new one. If I give you a binomial times a binomial, if you can do it in your head showing no work, good. If it's a yucky binomial times a yucky binomial, okay, Megan, I have no problem showing some work. And I'll show you what I mean. It wants us to determine the binomial products by completing the diagram. I'm actually going to pass on that. And we are going to jump right to example 2 right here. So find example 2A. I know the photocopier kind of flips the pages strangely when I double side. Anyways, I'm stuck with it. Find it okay, Kira? Yep, we're good. Okay, Curtis, you're good? Yes. Okay. It says, using the area diagram, you know what? Again, this is where I kind of find the pictures a little confusing. Let's simplify. Let's multiply this out. I just remember to myself, everything in the front times everything in the back. So usually what I do is I go this times this. And the first guy times the last guy. You called that front and outside. Negative 10x. Then you learned inside. I just remember the second guy times the first guy. Positive 1x. This is about the only time I will put the 1 there, just to remind myself that it's there. And then positive 1 times negative 5, which is negative 5. That's a 10 for those of you who are trying to read my hideous writing. And we gather like terms. 2x squareds, negative 10 plus 1, negative 9x minus 5. Put your pencils down for a second, look up, please. I would consider something like this straightforward enough that if you can do those in your head, if you can glance at these and say the answer is x squared plus 3x minus 18, that's great. I'm okay with you not showing any work. Would I show work on a quiz or a test semi? Probably. But would I show work in my homework? I'd try and do it here. If I even give you something like this, 3x minus 4, 2x plus 5, where you have coefficients in front of the x's as well. I'm okay with you doing these in your head if you can. Can you? Yeah? It's definitely going to be, I think, a 6x squared. The last number is going to be a negative 20. The middle one is always a tricky one. I just remember this. Doink, doink. Sorry, that's a bad drawing there. Doink, doink. It's a negative 8. And a positive 15. That's where the x's are going to come from. It's going to be a negative 7x. So if you can do them in your head, great. Now, if there's more than one variable, like b, or if there's different degree exponents, like c and d, then I probably, Victor, will choose to show work. Although I might try and, it's up to you. So, B. A times A squared, A times B, AB. B times A, also AB. B times B. And I got some like terms. This one's going to be A squared plus 2ab plus b squared. C. Are there exponents in there, Anthony? In C? Yeah, then I probably won't do this one in my head. I'm tempted, because it looks kind of clean otherwise. I might try and see if I can do it in my head. I might jot down the answer and then do the work. And if I got it right, I'd be like, woohoo! But let's go with this. Jack, x squared times x squared. What do we got? I totally agree with you. And then it's going to be x squared times positive 2, Jack. Keep going.
2x squared.
Positive 2x squared. I think the positive to remind me to put a plus sign there, right? And then, so first outside, or the first thing times everything.
Plus
Se-
5x squared.
I agree with you.
Plus 10.
Are there like terms I can gather?
Are you asking me?
Yeah.
Yeah, the 2x squared.
Okay, take it all the way home. What's the final answer?
X to the power of 4.
I agree.
Plus, 7x squared.
I agree.
10.
I agree. Nice job. D has got different types of exponents in each one. D, Ben, is where my bets are off. I'm gonna carefully foil this one out. I'll be honest. A, B, and C, if I was in a pinch, I would do them all in my head because I can't here. If you force me to do it in my head, probably Brody. I could keep track of everything in D, but this is just opening the room up for mistakes, especially if there was negatives in here. Then I'd just be, forget it. So you ready, Brody? What am I going to write with that? 3x cubed, I agree. Positive 3x squared. Positive 4x. Positive 4. Any like terms? No. Oh, and are we in descending order from biggest degree to smallest degree? Then I like that. That's a good answer. Okay. So we called this the distributive property if you turn the page. Some of your teachers may have called this the front door bomber method. I've never quite understood that, but that's okay. It says to multiply binomials. I'm not going to write a rule. I think you're getting the hang of it. You did it last year. So you learned the acronym FOIL, which stood for first, outside, inside, last. Let's try number 2 on your own. Number 3 on your own. And let's see if we get to the same thing. If you want to try doing them in your head, knock yourself out. But not literally. Jack, you okay?
Yeah.
Okay, a little focus here. Or is Jordan distracting you?
No.
Because I'll give him attention if you say the word.
No, it's fine.
You sure? Okay. So try doing 2 and 3. I don't know, I did it in my head. I think I'm right. Let me double check now. 9a, 10a, 19a, 6a squared, 50. I think 3 is right. 3x squared minus 2 plus 9 plus 7. I'm right, yeah? Woo. Let me reemphasize, though. I would never do this on a test. I would show my work. Right? Always more conscientious and careful on a test. Question? Okay. What's that right there? Read it out to me loud. 6a squared. I agree. So that's where that came from. What's that right there? Remember that. What's that right there? 10a? Remember that. Did you say 9a and 10a? What would that be if you gathered like terms? Oh, always gather like terms at the end, right? Now, Garrett, the nice thing is if you get the hang of doing them in your head, you can kind of get... I'll be honest. The way I do these, I multiply the first ones, I multiply the last ones, and then I do the like terms because that's the toughest to keep track of if I'm doing them in my head. Okay. Let's skip 4. Let's try 5. How do I do number 5? What is 5x minus 3 all squared? Is the answer 25x squared plus 9? No. You don't just square each term. It's this whole bracket. That squared there means this whole bracket times itself. Really, what I'm going to do is I'm going to scribble out that squared, and I'm going to quickly rewrite the bracket. That's what that means. It means that bracket times itself. Right? Good. Try it. Yep.
Is there any way you could like zoom it in a little bit?
Sure can.
Yeah.
Is that for Jordan? Yep. Who sat in the back row corner? Okay. Amber, am I right? Or am I wrong? I could be wrong.
Well, I did give minus 30x.
Okay, let's see. What's the,
25x squared.
check. Got it. What's that right there?
Negative 50 there.
Okay. What's that right there?
And then negative 15. X.
Ah. And what's the last one?
Positive 9.
Okay, so see where the positive 9 came from? Oh, can you see where the negative 30 came from?
Oh, yeah, like terms.
Like terms. Gather like terms, gather like terms, gather like terms. Okay. Does 6 have different exponents in each term? This one's going to be a bit yuckier. There may or may not be like terms to gather. Let's try this one. 3x squared plus 4, x plus 1. Here I'm not going to take any shortcuts. 3x squared times x, 3x cubed. 3x squared times positive 1, positive 3x squared. 4 times x, positive 4x. 4 times 1, positive 4. Oh! No like terms to gather. Okay. Next page. Is there a next page? No. Homework. So homework, page 166, number 5. Can you all open your books, please, to page 166? If you don't have a book, look at someone nearby. If no one at your table has a book, snag one from the shelf there, back there, and return it. Page 166, number 5. It says use algebra tiles. I'm just going to say FOIL them out, please. I think you can also do number 10. Number 12. But don't sketch a rectangle. It says to sketch a rectangle. Don't worry about that. And page 177, number 6, don't use tiles, just foil. 9, 10. That will be enough, I think. So let's talk about what I'm looking for in the homework. Okay. In your textbook, the answers are